Question 1.9. An object which is charged positively has A. Lost protons, B. Lost electrons, C. Gained protons, or D. Gained electrons. Objects cannot lose or gain protons at all. This means that we can eliminate option A and option C as right answers. We know that objects cannot lose or gain protons. So the answer cannot be A or C. So we are left with two options, either B or D. So the answer is either B or D. Objects can only lose or gain electrons. An object loses electrons when the object transfers its electrons to another object during a physical process such as touching or rubbing. An object gains electrons when electrons are transferred to the object by another object during a physical process such as touching or rubbing. When an object gains electrons, it becomes negatively charged. When an object loses electrons, it becomes positively charged. Therefore, the answer is B. An object which is positively charged has lost electrons, and that's how you will get your 2 marks. Question 1.4. A glass rod acquires a positive charge after it has been rubbed with a silk cloth. Which one of the following best explains why this happens? Is it A, negative charges are transferred from the silk cloth to the glass rod? B, positive charges are transferred from the glass rod to the silk cloth? C, negative charges are transferred from the glass rod to the silk cloth? Or D, positive charges are transferred from the silk cloth to the glass rod? Only negative charge can be transferred from one object to another during a physical process such as touching or rubbing. Let me repeat that. Only negative charge, which is carried by electrons, can move from one object to another, and that means that only negative charge can be transferred. Positive charge cannot be transferred because, as we said in the previous question, objects cannot lose or gain protons. Now this makes our job easier because it means that we can eliminate option B and D. So the answer cannot be D or D because positive charges cannot be transferred. Therefore, our answer is either A or C. You have a glass rod and a silk cloth, and you are going to rub these two materials together. When you do this, something called triboelectric charging takes place. Negative charge, meaning electrons, will move from one material to the other. So they will either move from the silk cloth to the glass rod or from the glass rod to the silk cloth. If negative charges or electrons are transferred from the glass rod to the silk cloth, the glass will have a shortage, a deficiency of electrons, meaning it will become positively charged. And the silk cloth will now have an extra or an excess of electrons, meaning it will become negatively charged. If, however, the electrons are transferred from the silk cloth to the glass rod during rubbing, the silk will now have a shortage or a deficiency of electrons, meaning it will become positively charged. And the glass will have an extra or an excess of electrons, meaning it will become negatively charged. Now, which situation do you think has happened? The first situation or the second situation? Did the negative charge move from the glass rod to the silk cloth, or from the silk cloth to the glass rod? The first situation happened because we are told that the glass rod became positively charged, meaning it lost electrons. So class transferred negative charges to the silk cloth and became positively charged. This means that C is the correct answer. Negative charges are transferred from the class rod to the silk cloth. So this is how you will get your 2 marks. Question 1.3. A perspex rod is charged negatively by rubbing it with a woolen cloth. During the charging process, A. Electrons are transferred from perspex rod to the woolen cloth. B. Electrons are transferred from the woolen cloth to the perspex rod. C. Protons are transferred from the perspex rod to the woolen cloth. Or D. Protons are transferred from the woolen cloth to the perspex cloth. This question is similar to the one we just did, right? And I'm sure you can already spot the answer. We have said that only negative charge can be transferred. This means positive charge or protons cannot be transferred at all. So from this, we can already eliminate 2 options. We can eliminate option C and D because protons cannot be transferred. Therefore, the answer is either A or B. You have a perspex rod and a woolen cloth, and you are going to rub these 2 materials together. When you do that, something called triboelectric charging takes place. This means that negative charge or electrons will move from one material to the other. If electrons or negative charge is transferred from the perspex rod to the woolen cloth, the perspex rod will have a shortage of electrons, meaning it will become positively charged, and the wooden cloth will now have an excess of electrons. It will have extra electrons, meaning it will become negatively charged. If, however, electrons are transferred from the woolen cloth, the negative charge is transferred from the woolen cloth, and those are electrons, the woolen cloth will now have a shortage or a deficiency of electrons, so it will become positively charged, and the perspex rod will have an excess. It will have extra electrons and hence become negatively charged. Which situation has happened? The first situation or the second situation? Did the charge move from the perspex rod to the woolen cloth, or from the woolen cloth to the perspex rod? The second situation happened because we are told that a perspex rod became negatively charged, meaning it gained electrons, or it gained negative and negative charge. This means that electrons were transferred from the woolen cloth to the perspex rod. So B is the correct answer. Negative charges or electrons are transferred from the woolen cloth to the perspex. So you will get your 2 marks. Question 1.4. If 2 charges are identical, with one having a charge Q, and they are brought together to touch each other and are then separated, the new charge on each will be A, Q, B, 2Q, C, half of a Q or half Q, 1 over 2Q, or D, 4Q. In situations like this, when 2 identical charges touch, the charges divide the net or the total amount of charge in half. This means that the 2 charges will now have equal amounts of charges after separating. This is due to the principle of conservation of charge, which tells us that the net charge of an isolated system remains constant during any physical process such as touching or rubbing. This means that we simply cannot just create new charge or destroy charge during a physical process. What happens is that when maybe two objects charge, charge is transferred from the one object to another. The amount of charge on each sphere can be determined using this expression after touching. The charge on each after touching and then separating is given by Q equals to Q1 plus Q2 divided by 2. Q1 is the amount of charge on charge 1 and Q2 is the amount of charge on charge Q. The amount of charge that each will have after, or the final amount of charge, is Q. So charge 1 had an initial charge amount of Q and charge 2 had an initial charge amount of Q. This means that the final charge Q is equals to Q plus Q divided by 2. Q plus Q is just 2Q. This means that we'll end up having 2Q divided by 2. And 2Q divided by 2 is just Q. This means that the final charge amount of each charge is Q. So the answer, or the correct answer, is A. Question 1.4. Two identical metal spheres, Y and Z or Y and Z, are suspended from long silk threads, as shown in the diagram below. The sphere Y carries an unknown positive charge, while sphere Z has a charge of negative 7 multiplied by 10 raised to the power of minus 9 coulombs. The spheres come into contact and then separate. The new charge on each sphere after separation is negative 5 multiplied by 10 raised to the power of minus 10 coulombs. Which of the following is the correct magnitude of charge on sphere Y before they touch? To answer this question, we need to first write down what is given, or the quantities that we know. We know that the final charge on each sphere after they have touched and separated is equals to Q, which is minus 5 multiplied by 10 raised to the power of minus 10 coulombs. We also know the initial charge, the before touching, that sphere Z had a charge of about minus 7 multiplied by 10 raised to the power of minus 9 coulombs. Let's call that Q1. This means we are actually looking for the charge on sphere Y. Let's call that Q2. And we want that charge in coulombs. And we will solve it using this expression that we also used in the previous questions, where it says that the final charge Q on each sphere after touching and separating equals to Q1, which is the initial charge on sphere Z, plus Q2, which is the initial charge on sphere Y, all divided by 2. We are looking for Q2. It means we need to rearrange the terms by making Q2 the subject of the formula. And we do that by cross multiplying. So to get the left-hand side of the equation, we will say 2 multiplied by Q, which is 2Q. And to get the right-hand side of the equation, we will say 1 multiplied by Q1 plus Q2. So we will actually end up with 2Q equals to Q1 plus Q2. Now we need to make Q2 the subject of the formula. It means that we need to take Q1 from the right-hand side of the equation to the left-hand side. And when we do that, we see that Q1 is positive. When it goes to the other side, it becomes negative. This means that 2Q minus Q1 equals to Q2. 2Q minus Q1 equals to Q2. Now it's just a matter of substituting the known values of Q and Q1 that we have written down. So we will just substitute and we'll find that Q2 equals to 2 open bracket minus 5 multiplied by 10 raised to the power of minus 10. You close that bracket, minus open a bracket minus 7 multiplied by 10 raised to the power of minus 9. Close the brackets. So it's important to open those brackets because we are working with very small numbers. We're also working with negative numbers. It's easy to lose track and make mistake when you are working with either very small numbers or very big numbers. So when you do that and you put this whole expression as it is on your calculator, you will find that the charge on Q2, the initial charge, this is the charge it had before the two spheres touched, equals to positive 6 multiplied by 10 raised to the power of minus 9 coulombs. So now that we know that, we can now go and look at our question and see which option is given by 6 multiplied by 10 minus 6 multiplied by 10 raised to the power of minus 9 coulombs. So if we have a look at all of these options, A, B, C, and D, we see that option B is the one that has the value of positive 6 multiplied by 10 raised to the power of minus 9 coulombs. This means that the answer is B. And we have come to the end of this lesson. Thank you so much for watching.